All right, so taking a look at C and D. I know you got through part A and part B, but it kind of gets context. For instance, there's a function f for how much snow is removed. I'm sorry, actually accumulates. I'm sorry about that. And you can use this as a calculator problem. You can integrate it, get the value. So there's in part A, you probably used a calculator, got that. And you can see the answer key for that. Then the next piece is in part B, find the rate of change of volume of snow in the driveway at 8 a.m. And the rate of change at 8 a.m. is a means of, since we're dealing with rates of change and these particular functions, we can look at there's an accumulation element, which is the integral here, and then, oops, I think we have an error here. There's supposed to be minuses in here. Just read this as minus. I fix them later, but, and then you're removing an hour's worth of 125 cubic feet per hour, and then an hour's worth, because remember that's 6 to 7, and that 125, and then the last one, an hour's worth of 7 to 8, 108 cubic feet per hour, 7 to 8, not 78. And so altogether, you accumulate, take away that 1 hour of 125 cubic feet per hour, and then take away an hour of 108 cubic feet per hour to get a total of negative 59.583, or however you want to round that. It could be up or down. That's a calculator issue. So assuming you got that okay, then going on to the next piece. Yeah, there we go. Fix those minuses. But do it later. The part C is, for any given t, you have to have a function that works. Well, if t is somewhere between 0 and 6, you got 0 accumulation. If you go from 6, if it lands anywhere between 6 and 7, we have that 0 accumulation plus whatever you get from 6 to time t in that interval 6 to 7. So 6t minus 125 times 6. And really, that if it happens to be 6.5 hours, or something between 6 and 7, you can plug that in and figure out how much accumulation happens. Then if it happens to be a time that lands somewhere between 7 and 9, you take all the accumulation from 6 to 7, all the accumulation from 0 to 6, which is 0, you put those together, that's 125. And then you add to it any accumulation that happened from 7 till 9 with a time somewhere between 7 and 9, so we just put t up there. So it depends. It really depends on your t. Your function changes. So for any given t that lands in a given interval, you have to use the appropriate function that goes with it. You can write it as a piecewise function that you can see in the answer key that they have for the AP problem, but the idea is that given a t of any value, you can add the appropriate accumulation to it. And then part D is stopping at a given time. All right, then to deal with what happens, how much snow is in the driveway at hour 9, or time 9 a.m., which is hour 9. You need to have how much accumulated versus also how much you shoveled out, given the g interval, or the g function that we came up before. So here's accumulation, 0 to 9 of f of t. And then you remove the 125 cubic feet that we got from hour 6 to 7. Remove the 108 cubic feet we got from hour 7 to 9. Actually, 108 times 2. Hang on a second. I put this in here in other places because there's 2 hours, so we got to take this times 2. So it's not minus 108. This is actually, if I put it in there, it's minus 216. Okay, the number is correct at the end, but you had an hour of 125, which gives you 125, and then 2 hours of 108 cubic feet per hour, so minus 216 from what you accumulate on 0 to 9 as the snow falls, and that's where you get the 26.335. So that's just an idea of where those numbers come from. The notation is different in the key, but the idea is the same. Hope that helps.